Hello students, welcome again. Yes, we will class tutorial classes. So last day, as previous, we discussed about the sets. We discussed about the what is a set, how to represent a set, the different type of set, how to represent the element, finite set, infinite set, non-set. We discussed everything. And today is a very important one. What type of operations we can conduct on the sets? That's we have to discuss here, right? So here we are having the heading is the operations on sets. A set where the elements are there, finite or infinite. Suppose we are considering two sets A and B, both are finite sets. Then we have to highlight or we have to point out what type of operations we can conduct on the set. Suppose the first operations we can highlight is the union of two sets. Suppose A and B are two finite sets. Then what type of operations are there? Union. The elements of the A union B are either the elements of set A or the set B, because the A union B is represents the elements, all elements of set and B, A and B together. So it is denoted as A union B. There are some conditions are given here. If I consider A union B is a set, then A is a subset of A union B. That similarly B is also a subset of A union B. A union a null set, a set A where the elements are finite, and if it is union with a null set, then the result is A. Similarly, if I conduct A union A and say union with the same set, the result is the answer is also A. A union B and is equal to B union A. We can write down at the set A and set B both are B. If we have conduct operations union, we can write down the B first and then A. Here we consider three finite sets A, B and C. Then that properties are also there. A union B intersection C. If I break the bracket, you will get A union B intersection B A union C. And A union B is equal to 5. If I get the union of two sets, its result is 5 is null set. Then definitely the set A is 5 and set B is also 5. This is a very important. Some rules, some features are given related to the union of sets. And then similarly, if I come to the intersection of two sets, A and B both are finite sets. And if we do the intersection of the set A and B, then obviously the elements of the sets A intersection B are the elements of either A or B. Right? So here we write A intersection B is a subset of A, or A intersection B is a subset of B. The elements are present both in A and B. That's why these are called elements of A intersection B. Similarly, some features are given. A intersection 5 always give us result is 5. 5 is a null set. A intersection A, the result is A. A intersection B is equal to B intersection A, because A intersection B or B intersection A is always contains the elements that elements present in both are in A and B. And then we come to the difference of two sets. Here we have discussed about union of sets. Here we discuss about the intersection of sets, and there is a difference of two sets. Suppose two finite sets A and B, and we write down A minus B. If A minus B is equal to X, right? A minus B is equal to X. What is X? X are the elements. That elements are present in A but not in B. A minus B represents X, means X is the element that is present in A but not in B. Similarly, if I wrote here B minus A is equal to Y, that means Y the element that is the elements of B but not in A. So, wherever we have done the difference of two sets, difference of two sets, then automatically we will have A minus B or B minus A. We can express in this way. And while discussing on the operation of sets, there is a very important rules given, that is the De Morgan's law. That laws are related to the complements of the sets. We already discussed about the complements. What is the complements of the set? If I consider a set of natural numbers, then the natural number is a set of, then the complements of the number, all numbers except the natural numbers in the universe. That's called the complements of sets. So here we are making A and B are two finite sets. Then A union B intersection of complements, we can say A union B complements is equal to A complement intersection B complement, and we can highlight here by the Venn diagram also. So here A union B complement is equal to A complement intersection B complement, and B intersection A intersection B complement is equal to A complement union B complement. is a very important rule while we do the sum of the sets while operations on set. So we discuss here about the operations on set. For further more, please go to our channel, YouTube channels, DICB class, tutorial classes, and continue. We will continue. Thank you.